Today we're still working on gravity center. Gravity or Centroid. Okay. So last time we were talking about if we have multiple objects in a three-dimensional space, and we treat everything as a dot, and let's say this is x, this is y, this is z, and this is w1, w2, wz3, and when we determine their locations, it's going to be x1, y1, z1, or w1 or w2 is x2, y2, z2, or w3 is x3, y3, and z3. Now, if we want to determine their center of gravity, then we use x bar to represent the position, and we have numerator as w1 plus w2 plus w3, and in the denominator we have w1 plus w2 plus w3. In the numerator we have x1 tilde multiplied by w1 plus x2 tilde multiplied by w2 plus x3 tilde multiplied by w3. So with this formula, we should be able to determine the center of gravity of those three objects. Then for y, the denominator is always the same. The numerator is always the position of individual parts multiplied by the weight of individual parts. Z direction remains the same, which is like this. You should be able to find those formulas in your notes. Okay. That is something we call center of gravity. However, we are not always looking for center of gravity. Instead, we might have different kind of centroid that we need to find out, including the center of mass, center of volume, center of area, center of line. So all those information counts as centroids. However, a lot of times we're not looking for discrete objects like this, which means all the objects are treated as point information. So you know the weight of individual dots, you know the position of individual dots. In a lot of cases, it's not going to happen. For instance, you might want to find something like this. It has its own geometry. So in this case, you might find the shape over here is a specific function. We might say this is function of x, y, and z. So something like this. So we might be able to find the total weight of this thing. However, be a little bit different because we will need to know the individual position of x position, y position, and z position divided by its total weight. So instead of using discrete type of formula, we would need to use integration to solve for everything. Actually, those two sets of formula are identical. The only difference is we either use summation or use integration, because over here we can always replace the formula over here with something like this. So over here, you pretty much can see those two equations are identical. The only difference between those two sets are either use integration sign or using summation sign. But other than that, every other thing remains the same. Any questions so far? So the formula I'm showing you over here is related to the weight. So we can say this is center of gravity because weight is related to gravity. However, if we simply replace the differentiation term over here, you can replace this into anything. If you want to find center of length, you just replace this part as dl and this part as dl as well. And do the calculation, you're going to find the center of length. If you want to find center of area, then over here, you just replace this as A, and here you replace as A, so you can find center of area. If you want to find volume, it's going to be the same. The only thing you might need to worry about is how are you going to identify the formula over here. And one other thing is, when we say dW or dA or dV, they are not the function. In this case, they are not function of x. So if you try to get the information, it might be a little bit difficult or not so straightforward. You must convert everything as a function in terms of x, then replace this part as a function of x. So something you are going to have is going to look like this. It will make your integration a lot easier than just deal with the dW, dA, or dV term. Okay. Let's do one of the example. Oh, by the way, in this chapter, you don't need to do any free body diagram because in this chapter and chapter 10, we don't have any force involved. All those two chapters are talking about some basic property, locations and inertias of a specific object. So you don't need to worry about the force information because we are not going to discuss whether it's in static position or it's going to move. Those kind of conditions. So Newton's second law are not going to be used in those two chapters. So I have area look like this. The bottom over here is a straight line. The side of the vertical part over here is another straight line. But to connect between the origin and the endpoint is a curve which is a function of x. So I would like to know the centroid of area used in this of this area. So we are given an area. We want to find center of area. So when we try to find the center of area, the equation over here needs to be modified a little bit. And one other thing is, since this area is a function, is a mathematical function, it's not discrete type of combinations. So instead of using this set of formula, we will need to use this set of formula, and we need to change the equation or formula over there a little bit, because instead of using W, we need to use area over here, which means it's going to be okay. So when you see this, those two equations, you might wonder, how am I going to integrate area? Because area is a two-dimensional information. So how can I do two-dimensional integration with a single integration sign? So it depends on how you're going to integrate area, because when we say the A, it actually slices this into pieces. You can say this is just a single pieces over here, but I wouldn't suggest you do that because it can be very, very tedious and very, very long calculation. So instead of doing that, we cut everything into small sizes over here, and then this part as dx. So if the location of this one is x, can we know the height? Certainly we can, because the formula is given. Does that make sense? So what is the A? In this case, it's going to be, what is the definition of an area for a rectangle? Bottom multiplied by height. So the height here is y. The bottom over here is dx. Everybody agree with me? And y in this case is what? X squared. So the area, instead of using dA, we can convert that into x squared dx. So instead of using this function, we make everything as a function of x. Does that make sense? So A, let's start with this part, becomes A dA, or x squared dx. How do we determine the integration range over here? Do we know its starting point based on this configuration? We start from where? 0. And where we end? 1. Okay, very good. So when we have this kind of information, this is straightforward, right? It becomes 1. So the area of this shadow part over here is 1/3. Does that make sense to everybody? Okay, so those two parts we no longer need to worry about. let's deal with x first. It becomes x, the position of this specific area, multiplied by the a. The a is something we just derived over here, divided by a. A is something we calculated already. So on the numerator part, it's again, you need to determine the range of this integration. Where we start? Where do we start? Where do we start to do the integration? 0, right? Where we end the calculation? 1, right? So over here, this is straightforward, right? Since we are integrating x cubed, it becomes what? Fourth order divided by 4, starting from 0, and at 1. Denominator is 1/3. Over here, this is what? 1/4, right? So if you do the calculation, you're going to find this is actually in x direction. Is that clear? Everybody understand what I'm talking about? Is that clear? Okay. The next step we need to do is y direction. Y direction is going to be a little bit tricky, but still it's not so difficult to understand. We would need to determine the location of the y tilde over here. Over here, x tilde equals to x. Well, y tilde equals to what? The center of area of this piece. Is there anybody? Can anybody tell me where should the center of mass located? Should be located. One half, right? It's here. It's always in the middle because when we are talking about the center of anything, if the material is homogeneous, we always talking about it at the center. If it's a rectangle, and I don't think we're going to do anything other than rectangle in this class, because if you are doing triangle differentiation, it's going to be very tedious to integrate. And normally when we are talking about definition in calculus integration, we're always talking about small rectangle shape. So over here, when we say it's in the middle, it's going to be, this is y, right? 1/2 y, or it is what? Does that make sense? So when we try to do the calculation over here, y becomes y a. And since I'm talking about replacing y tilde with x, it becomes x squared over 2. The a is something we found here already. That is x squared dx. So again, you need to determine the range, integration range. Where do we start? 0, right? Where do we end? 1. So over here, this is 1/3, which calculated over here. On top of this thing, it should be straightforward to calculate, because if you multiply those two things together, it becomes x to the power of 4 divided by 2. So when you do the integration, it becomes the fifth order divided by 10. Starting from 0, ends at 1, divided by 1/3. Over here, since we end at 1 start from 0, this one is 1/10. 1/10 divided by 1/3, we actually get 0.3 meter. And those two are our answers, or you can space by that somewhere, which make me easier to grade. Should be around somewhere here. So it should be somewhere here. The center of gravity is going to be somewhere around this place. Does that make sense to everybody? Is that clear? So, for this kind of problem, actually, it's not testing your integration technique. In one way, it is how are you going to find, because if this is area, so you need to use A. So how do you find the A in terms of either it's going to be X or Y? If you're not doing the center of area, you're doing center of volume, how are you going to identify the equation dV in terms of X or Y? So those are information, or those are techniques you need to do. Once you figure out the function, like we have over here and we have over here, the integration should be straightforward. As long as you don't make any mistake, the integration part should not be a problem, but you need to know how to find the corresponding function in terms of X and Y, or Y. That's the most important things over here. Any question? Okay. For center of area, it's like the center of mass is similar, but if you're talking about center of line, it will be a little bit different. I'm going to explain two examples over here. Those are in your textbook. So we would like to know the centroid of this rod. Obviously, this looks like a single one, right? So when we say it's a centroid of this thing, we're actually looking for center of line, because this is actually a line. So how are we going to deal with that? Center of line. Okay, so how do we start? Since we know it's going to be center of line, it means that in this case we're looking for what am I looking? Let's say this is my DL. Let's type it over here. This is my DL. So if you project this part, in this case, if it's small enough, this becomes linear or just a slope. It's no longer a curve. Everybody agree with me? So if that's the case, we can project that into x direction and y direction. Over here, this is dy. Over here, this is dx. Agree? So you know triangular relationship, right? So you know that the L squared equals to dx squared plus dy squared. Or we can say dl equals to dx squared plus dy. So far, everybody okay with the representation I'm having over here? So if I do something like divide by dy squared if I divide dy squared on both sides and move dy out of the square root term, it becomes something like this. Or it is actually something like this. Talking about over here, and we got the relationship. We kind of convert dl with dy. We can represent everything like this. So since we can represent that, let's work on the x bar. So x bar is something we define over here. That is x right? I'm not doing anything. X remains the same. Replace dl with something we just found over here. Divided by since we know it's in terms of y and we know the range of y, that is 0 to 1. So we can just plug things over here. And in this case, I also need to replace x with y. In this case, we know x equals to y squared. So you just do something like this. Well, for some reason I think this part is a little bit tedious. I'm not going to go through this part. But if you know how to, if you look up your integration table, you should be able to know the formula corresponding to something like this over here. Okay. Then, if you do y, it's similar. So if you do your calculation, this is 0.41. This is 0.574 meter. Those are the answers. Okay. The point over here is how are you going to identify the property in the differential term over here and represent this term in terms of x or y. If it's two-dimensional calculation, if it's three-dimensional information, you might consider z as well. But as long as you find those how to convert from, in this case, dl as a function of dy, then you just integrate along y-axis, then you'll be done. If you don't like doing that, you prefer to do in terms of x, you just find the corresponding functions, and you should be okay integrating everything together. However, I'm going to anticipate it's going to be a little bit more tedious if you use dx in this case, because x equals to y squared, dx equals to y to y. So y is going to be dx over 2y, or x. Becomes something like this. And you have another square x term over here, which is going to make your calculation a whole lot of more difficult. So I wouldn't suggest you doing that. But that's another way of doing this kind of problem. Okay. Any questions? Is that clear? Everybody understand what I'm doing other than the integration part? I know the integration part is a little bit tedious.
For the y bar equation, why is that still like in terms of dy? Like over to the right, all the way to the right?
Here?
Yeah, why is that not in terms of dx?
Because I'm dealing with everything in terms of y. I can do that as dx, but I just explained that. If you use dx, everything must be dx, though the integration term is going to be the same. But because dx has two square root x over here.
Okay, I just thought that it would like flip to be opposite, but I guess not.
No, it's not. I would not recommend you doing x term. It's just crazy. So I would, other than that, I'm going to show you another way of doing this kind of problem, because normally we are using the coordinate in terms of x and y. However, it's not always the case, in particular in mechanics problems. Sometimes you need to know radius and angle. So it means that I'm dealing with things on a circle. So if we have a circle, what am I going to do? Still, this is centroid. I try to find the centroid of this rod, and in this case, this rod is 1/4 of a circle. So how am I going to do? So obviously, this is my x, this is my y, and the height is r. The bottom is also r, because it's a circular shape. So what am I going to do with this thing if I want to find the central? So I'm given in this case, this is center of y. Again, so let's solve that. So since I know this one is circular, I would like to use a little bit different. If I this one over here is the theta. Of course, I know that my theta is kind of small, not like so large just for representation in class. So over here is my dl. The radius is r, which is given. So by definition, dl equals to what? R d theta. Right? So can we know the x direction in this case? We do, right? Because we know x equals to what? If you take something over here, so we know this theta, and it just adds a little bit over here, that's my d theta, which almost ignorable. So over here, this is my r, this is my theta, this is what? R sine theta. Is that clear? Everybody understand what I'm showing here? Should not be so difficult to understand. Now, what are we going to do? We are still dealing with the definition of center of light, which means I'm still using those two equations. Then we can replace dl with information which corresponds to the theta. And over here, the triangular relationship over here, I totally get rid of information of dx and dy. Instead, I'm using theta as my integrated for function. But in this case, the range is something you need to determine. We are not, for integration, we are not integrated using degree. Normally, we integrate using the term of radius. So in this case, what is my range of angle?
0 to pi over 2.
Right, 0 to pi over 2. Very good. So we can do r first, because over here is actually from 0 to pi over 2. And we are talking about r is theta. So if we do the integration, it's actually r that is going to be right. Any question for the integration over here? Now, we would like to deal with x. So in this case, we know that x is r cosine theta. We know the DL term over here is R theta from 0 to pi over 2. In the denominator is pi r over 2. So if you do that, you can take r squared out of the integration term because r is a constant. So everything in this integration becomes cosine theta, theta over here still pi r over 2. We can cancel out r over here. So it's going to be 2r pi. When you integrate this cosine theta, what do you get? Sine theta. Everybody knows that, right? It's in your calculus class. That is something I'm not going to give you formula or emphasize in the exam. That is something you need to know already. Okay. So it becomes sine theta, range is 0 on pi over 2. What do I get over here? Sine 90 degrees is what? 1. Sine 0 is what? 0. So this term over here becomes. So the answer for this part is 2r over pi. Is that clear? Everybody understand what I'm talking about? Does that make sense to everybody? Okay. Actually, you only need to do till here, then you should finish because this is symmetric. So it should be x and y should be at the same location. I think it's somewhere over here. But I'm still going to verify that if your answer for y square, for y bar is not the same, you're doing something wrong because it should be symmetric. Let's use the other side. What I mean is y is from 0 to pi over 2. What is my y tilde term over here? R sine theta. What is my DL?
R theta.
R theta. R theta. In the denominator, we have derived that already, which is pi r over 2. So again, I can just take r squared out of the integration and leave the integration with cosine theta only. So over here, is 2r over pi for the constant part. In the integration part, when you integrate, cosine becomes what? Sorry, I made a mistake. When you integrate the sine, what do you get? Negative cosine, right? What is cosine 90 degree? 0. What is cosine 0? Cosine 0 degree? 1. So this number becomes 1, right? Because 0 minus.
Yeah, that's right, because it'll be minus, so it'll be minus negative 1.
Positive. Awesome. Am I doing anything wrong over here?
No, because it'll change to positive because you're going to.
Okay, anyway, I know this part is going to be a fun. So, the answer is going to be the same. If you fail to get something like this, identical to this side, you're doing something wrong. Because, as I said, this is circular. It should be symmetric. If you are not getting symmetric answer, then you're doing something wrong. But that is how we deal with how. So over here, I give you guys several different cases. How are we going to replace the A or DL with either is dx, dy, or another information or d theta? Then just use what you learned in your calculus. You should be able to find out all the information and doing the integration without any problem. It's going to be a little bit tedious if we change those kind of things, but that's the basically how we process the calculation of centroids. Let's take a 5-minute break. And you would need to convert everything in function of x, y, or z, or r theta, so you can do the integration. But you also need to know how you're going to derive, how to get the information after integration. So normally I would say using integration is physically wise, it's make more sense, but calculation wise, it's sometimes a lot harder, a lot more complex compared to discrete type thing. So most of the problem you guys are going to encounter in the future is actually not continuous component, but how are you going to decouple everything into pieces and use summation information to get the centroids? That is something you guys will need to know. And we're going to talk about some examples here, but when we are doing that, I would like you guys to follow 2 steps. One is identify what are given and what you need to find as usual. Because a lot of time, when you see an area like this, what is your assumption? You're trying to find the center of area, right? But what if I'm telling you this part is made by wood, this part is made by steel, and I'm asking you find me the center of gravity? Then you just put everything together in terms of area. Are you going to get the correct answer? Of course not. So when you are doing those kind of solving this kind of problem, be sure you read through the problem statement and understand what are given and what you really need to find. Okay, that's the most important thing you need to do, because I think there is one semester I just put something similar problem and tell them the density of this one is what, the density of this one is what, and ask them to give me the center of gravity. And over 60% of the students give me the answer, center of area. So just be careful. Okay. Okay. So when you identify this kind of problem, what is the next thing you need to do? Since we know this is not a function, and you probably won't be able to find the function so easily to describe something like this with a hole over here. So instead of using integration, divide the given component into several simple geometry. Okay, so in this case, what are you going to look at? You have a triangle, you have a square, you have a semicircle. Then the next step, establish a table. Identify. Required information. Most of them is going to be X, Y, A, L, or what, those kind of things. Then the next step is find Centroid. This step is, I would say, the easiest one, because if you know the formula, there is nothing fancy over here. But you would need to know, establish a table for this thing, so you really know what's going on. Let's do this example, and we know what I'm talking about. I've given a mechanical component. Okay. For you guys who has notes with you, what am I trying to find? What am I trying to find? No, none of you have.
Centroid.
Yeah, no, it's Centroid. Centroid what? None of you have notes. In center, area. This is important because I'm not talking about weight, I'm not talking about line, I'm talking about area. So when you put the table together, this is important information you would need to know. I might need to do something over to show me the origin. Okay. So because when we start to talk about when we start to do the table, there are two things essential we need to know: X and Y. And those are not absolute value, it's actually a relative value depending on where your origin is located. So you would need to determine where you want to do. So in other words, I'm not going to ask you guys to give me an, if you use different origin, the answer is going to be different. Normally I would start from this point over here, simply because in most of cases, I would like to start using this kind of coordinate. So this one is my 0, 0. That's the only reason. But in this case, if you want to say this is my 0, 0, that's also fine, because I cannot say your answer is wrong. It's just make your numerical calculation a little bit different from the other, from the result of other students, but that's also fine. Over here, how many pieces are we going to divide this component? 1, 2, 3. 3. So the first one, what do you want to do your first one? The triangle. Okay. So I know this is going to be 6 inch. And this one 6 inch. What is my second piece? Square. And the third piece is for sure the semicircle. The radius is 2 inch. Okay. Then I would like to fill let's name this one A1, A2, and A3. So I will have A1, A2, A3. In order to find the centroid or center of area, what are the information that we need to have before we actually apply the formula? We need to know x tilde, y tilde, and a. Right? So let's do A1. Area of A1 is straightforward, right? Everybody know how to find the area of a triangle, right? It's 1/2, 1.56, 1.6, so it's going to be 18 squared, so 32. I would like to use this one as my origin. So I will use this one as my 0, 0 and use that to determine my x tilde and y tilde for all the components. Okay? But how do we find x tilde and y tilde? Well, I believe I told you guys it's 2/3 from the bottom when we are solving the problem earlier in previous chapter, right? But over here I'll do the calculation for once, and after I show you guys how to obtain that, I'm not going to do that again. I'll just assume you guys remember that, and this is something you need to know when you are dealing with the final. So I have x1. What is the function over here? Y equals to x, right? Because this is 1, this is 1, this is just a ratio. Y equals to x. So x over here is going to be y dx. And over here, this is going to be y dx is dA, because it's going to be y dx, just like what we did earlier today. It's going to be y multiplied by dx, which is over here, here, and we know we're looking for the range 0 to 6. Can I replace y with a function of x? Yes, right, and y equals to x in this case. So essentially, what you're going to have is going to be x squared dx or this is going to be or it's going to be 2/3 x. Right? So it starts from here to here. It's 2/3 from the point over here and 1/3 from the bottom, from here to here. Does that make sense to everybody? So in this case, where is my x tilde 1? If x equals, grading 0.6, 4, right? It's going to be 4 inches. So far, any question? Is that straightforward? You guys understand what I'm talking about? Okay. For things over here, it's actually same. You can just do on the bottom, or you can do the calculation. if you want to integrate everything in terms of x, let's do this on the other side. It's just too small over here. So y delta is going to be it's going to be, in this case, it's going to be what? 1/2 y, right? So it's going to be 1/2 y multiplied by x, or it's actually at 1/2 out. Those two for this part are actually identical. So if you do the calculation, you're going to find this is actually 2 inches. Okay. So I found the area. I found x tilde 1, and I found x1 tilde and y1 tilde. So I just fill in the blanks in the table. That's for the first shape. Yes.
On the test, if we're trying to find these, if it's just like common sense, do we have to show like all like
No,
the
you don't need to do this.
Okay.
No, just use the formula. That's something I'm telling you. I'm going to show you guys just once. From now on, you just assume you know that. Okay, don't waste your time since you know what's going on. But you do need to know where this one is related to the origin. That's the most important thing, because most of you guys is going to give me something wrong when you are putting over here. Let me explain to you. So for this square over here, where is the centroid? Or where is the centroid of this guy?
3.
In the middle, 3 and 3. Can you put 3 and 3 over here?
No, you have to add 6.
Right. That's what I mean. Okay? Just don't put 3 over here. You need to know where you start everything. So for A2, that's straightforward. Okay, in the exam, just don't put a table without calculation procedure. Even though you don't need to show me something like this, you still want to tell me this is 2/3 or 1/3 from where. Just make it clear so I know you're not copying from your neighbor. Okay, that is the most important thing I need to know. You need to include all the calculation procedures, even though I know this is some kind of trivial, everybody knows it, you still need to show me how you get that. Okay. And okay. For the semicircle over here, A3 equals to 1/2 pi r squared. In this case, r is 2. So if you do the calculation, you're going to find right? However, there is something you need to know. Is this a piece that fill in the hole, or this is actually a cutout piece? When it's a cutout piece, we are going to use negative in front of it. Because you are not adding weight to the component, you actually remove some weight from the component. So when we are calculating the total area, instead of this part is count the whole thing as a complete shape, but we need to cut this out. So you will need to put a negative sign in front of it. This is something you need to be careful. Okay. Other than that, what is x3 tilde? It's going to be in the middle, 2 inch, but this is actually 9 inch away from the origin. Does that make sense? So it's going to be 9 over here. This part you can do. You can just do the integration if you like, but in most of the cases, I would suggest you just memorize the formula because it will be used in this chapter. It will also be used in the next chapter, in chapter 10. That is going to be 4r over 3 pi. In this case, my r is 2 inches. So if you plug in this number over here, it's going to be 0.849 inches. So just put it here. Now we got all the required information. We just assemble everything together in the equation, which we use in step 4. So we're going to have what? X equals to W1, A1 plus A2 plus A3 X tilde X1 tilde A1 X2 tilde A2 plus X3 tilde A3. Plug in the number. That's my x. For my y, it will be the same. It's going to be 18 plus 36 minus 6.2, 28. And over here it's going to be 2.55, 18 plus 3.55, 36 minus that is going to be 2.91. So this one and this one are my answer. Is that clear? Everybody understand what I'm doing? So in chapter 9 and chapter 10, I would say it's easier, though it's not necessary. But I would suggest you guys just put a table and put the required information in the table, so it will be easier for you to find information when you try to put everything together in the big equation. Does that make sense? Okay. Okay, I still have 8 minutes. I still possible to go through one more example. This weekend. Yes.
When we found Y3 up there, you mentioned you should just memorize that formula.
Yes.
What's that formula from?
In your back of your textbook,
Okay.
there is a table of everything. you can find cylinder, you can find cone, you can find everything, but those things normally we don't use. But this one, semicircle, we encounter this kind of shape because we are in class. So semicircle is one thing we always need to figure out, because if it's a circle, then we don't need to figure it's always in the middle. But semicircle is something you need to know. I think in one semester I deal with a lot of quadrant circles. I kind of removed those kind of problems from the notes, but it's still common. So I can almost ensure you guys I'm not going to put this in the exam, because I don't want you guys to memorize too many equations. Yeah, you use up all your memory, right? So